This is great. It feels great to participate in something like this. So just to check real quick, can you see my screen and me? And okay, thumbs up. Cool. You know, like I was saying, it just feels really good to participate in something like this. Yes, it's virtual, but it's great to see, you know, the community of attendees and our wonderful partners on the screen as well. So just wanted to say thank you again for having us, and thanks for everyone sticking with us today. I hope, like I was saying, I hope you had a great lunch, and that you have some coffee to go with it afterwards, like a typical conference, to help stay awake here for the afternoon sessions. What Kai and I are going to talk about today is about the edge, and I think many of the presenters today are talking about the edge as well, which is very interesting. And so we're going to talk about like some software. I know we had some hardware sandwiched in, so that's great to have the software between two good hardware partners. Software and then some just general technology. We wanted to make this you know, really more of an educational event, so that's when Kyle's going to take over and talk about containerization and how that can help when you're deploying software and hardware at the edge. So just to get the conversation started, I am going to briefly talk about a new offering from Kepware called Thingworks Kepler Edge. So if you're familiar with Kepware, I won't go too much into what Kepware does, but if you're familiar with Kepware, you know, we are known as the driver company. We have 150 drivers for our traditional Kepserver EX product that unfortunately only runs on Windows. And over the years, we've been asked to remove those Windows dependencies and have an offering that could run in, say, a Linux environment. So that's something we've been working on recently through all of our developers on it for a while. And a few months ago, we finally released version 1.0 of this offering, again called Thingworks Kepler Edge. So it's the same, you know, code base as the Kepware technology or Kepserver EX code base that you know, has been used in many locations over many years, but with the Windows dependencies removed. So in that it is a version 1.0, it's limited in its connectivity compared to Kepserver EX, but we'll eventually catch up. But the very first release has our top 3, you know, selling drivers, the ones that are used the most, and that is the Allen Bradley Control Logics driver, the Siemens S7 driver, and Modbus Ethernet driver. And then from a northbound, and that's what we call our southbound connectivity, our drivers. And then from a northbound, what we have to offer is OPC UA, MQTT, and the Thingworks Always On protocol. And you can configure it remotely using our third-party RESTful client. So that's also really helpful when you're doing deployments of, you know, hopefully many of these across your enterprise. The 2 initial target markets to help set the stage here that we, you know, heard most from the industry as far as like why they wanted a version of this that would run in Linux, you know, in a smaller footprint device. One is machine builders, and the other one is, you know, kind of, I say upstream and midstream oil and gas. It's really, you know, any type of remote operations. You know, in the energy space, there's obviously a lot of that, utilities as well. But for machine builders, you know, they want to not just sell a machine to a customer, they want to, you know, provide that machine as a service. They want to be able to communicate, stay connected to that machine, understand how the customer is using it, understand how the machine's performing, and be able to ultimately service it as best possible. And to do that, they sometimes will need local connectivity to PLCs that are either on the machine they build or on other machines that are in the same factory that they need that connectivity to be able to perform its functions. And then for the upstream and midstream oil and gas example, you know, they have all kinds of challenges when collecting data in that space. You know, they have network outages due to weather and other environmental things that come up. They are usually on wireless networks and often have to pay to transmit data, and it's usually low bandwidth networks, so you can't get a whole lot of data across there. And like the traditional way of polling is pretty inefficient. And that's bad enough for just SCADA data, but now that we're entering like this IoT where we have advanced analytics that need much higher frequent data, that traditional architecture just isn't going to work. So I do have a video to share, and if you should be able to hear this. If you can't, that's fine. We'll just give me a notice and we'll just move on. Let's go ahead and get it playing.
Offering high-quality industrial machines is what you do best. But customers are demanding connectivity features in the machines you make for them, and they want it at competitive prices. There's the option to develop your own connectivity software, but that's expensive. You don't have the team for it, and it's difficult to hire for. Outsourcing is another option, but that's just paying someone else to develop a custom solution. With Thingworks Kepware Edge, you have a quicker and more cost-effective choice. It offers out-of-the-box connectivity, so you can build smart, connected machines without writing custom code. It has the best-in-class security and reliability of Kepware, so your customers will feel comfortable relying on it for critical production data. It's Linux-based too, so you can add it to every machine without re-platforming or breaking your budget. Thingworks Kepware Edge allows you to offer customers what they've been asking for: connected machines that work with their on-site applications. And since it also connects to cloud-based IoT platforms, including native integration with Thingworks, you can access machine data to deliver new services or business models. Ready to connect your machines with a platform that's secure, efficient, and IoT-ready? Download the demo today and experience how Thingworks Kepware Edge can benefit your business.
Okay. All right, on to the next slide. Just want to confirm. Looks good. So this, gives you a real simple architecture of what that machine builder's data collection, might look like with having that Thingworks Kepler Edge loaded on their local machine. They're able to connect to a variety of PLCs and provide that data to not just a local SCADA system, perhaps that's on the shop floor. They could also provide it to their cloud, meaning like allowing them to stay connected to the machine. And then if the user has their own cloud that they want to get that machine data, up into the enterprise, for instance, for whatever reason, for IoT purposes, they have that ability as well. Now, I have spent a lot of time in the oil and gas industry, so that this kind of stuff excites me, but I know probably most people in this crowd maybe not so. But it is a really good stage to be set for the second half of this presentation. I think this is my last slide before I hand it over to Kyle to talk about more like deployments, but we'll get to that here as to why that's going to be important. So in a typical, let's say, upstream oil and gas, you have a variety of devices that are controlling things out in the field. And this is just, for instance, for one well site. You could have a flow computer, you could have a PLC, and you could have a pump jack controller that's doing artificial lift. And then the traditional architecture, so Thingworks Kepware Server is now the rebranded version of Kep Server EX. I should probably mention that. And again, that's the Windows version of the product. That's why you kind of see the Windows logo there. So in this regards, we're used as a polling engine. So we poll all of these devices, and this example is just for one well site. So there might be 1,000 well sites from a particular company who's using this one server to try to communicate real-time data as well as measurement data from the PLC and the Dynacard data, which is specific to those pump jacks. That is just a lot of data collection. And with the typical poll response mechanisms that the traditional protocols would use, that's a lot of back and forth for all these devices. And sometimes the actual data points in these devices aren't necessarily changing all the time, but unless that polling engine asks the question, it doesn't know that data point, what's the current value of that data point. And then it gets the data and provides it to, typical SCADA systems, historians. The measurement data might go into a measurement or gas balancing back office accounting system. And then if you wanted, so that's yesterday's SCADA network or SCADA architecture. If you wanted to get that data then into something other than SCADA. It could be into your enterprise. It could be into, an Azure or AWS cloud, where you're able to do more interesting things with it. You had to like get that SCADA data out of SCADA, which was never designed to kind of share data outside of the four walls of that SCADA system. So a lot of development, custom development would have to be done to get that SCADA data out into the cloud. And there's problems with that. Very coding intensive to do that. A lot of ETL functionality required. This whole architecture, I mentioned the poll response. It's an inefficient way to find out the data that some data points haven't changed. A lot of those devices out in the field are Modbus. That's an insecure protocol, so that's not great either. When the network goes down, you're operating in the dark. When that low bandwidth wireless network goes down for whatever reason, which happens a lot, that SCADA system, that polling engine's not able to get data from those devices, and you're in a blackout period during that time. And with just typical SCADA purposes, it's barely able to get all that data that's needed. And sometimes, SCADA data could be 1 minute data or 5 minute data, depending on how critical that data point is. But if you're trying to build machine learning models to do, all the wonderful stuff that advanced analytics promises to do, like you need much more frequent data to be able to do that. And that's just something that's not possible with this architecture. So that's what brings us to the edge. That it was a traditional architecture. This is an edge architecture where if you take that polling engine, instead of that polling engine, I should have mentioned that polling engine in that, let me just go back real quick. And that previous slide is probably in Houston, at a server room, closet, whatever, in Houston, Dallas, Denver, the typical oil and gas hotspots. Now the data collectors, these smaller versions of Kepware, you could call it, and smaller type gateway devices too, not full line server type hardware, are pushed out into the field, and now they're directly connected to the data sources at a local area network. So that takes care of the security problems. It also takes care of being able to collect much higher frequent data, because you're not trying to do that data collection over the low bandwidth network. And then using a more modern protocol like MQTT, which has the ability to do a publish subscribe type sharing of data. Now, if it only time that data is sent across that network is if that Kepler Edge server in the field has a changed data point. So if the data point's not changing, it's not sending any data. So instead of calling me, I will call you. I will let you know when there's a data change. So that is great. Like I said, security is improved. You're able to get much more frequent data, and then only share the data when it changes. And then with like local buffering of data in that now you have the gateway device out in the field. If that network goes down, that data could be buffered and then shared later once that network comes back online. And again, for like machine learning purposes, in order to develop those models, they're going to need that full picture of data. So again, that's better from a data collection standpoint.
Hey,
all right, so yeah.
Quick comment question for you. So this is a fantastic reference architecture and example of more distributed.
Pretty basic. Yeah.
How do you see Thingworks Kepler Edge could fit more of a traditional like plant application, whether it be manufacturing plant or a water utility? What do you think about that?
Yeah, I mean, like I said, I chose to use this slide because I'm most comfortable with it, and it really just makes sense when you're out there in the field at the edge. In a factory setting, we gave the machine builder example, but even that's the machine builder, the maker of that machine wanting to provide connectivity. But for the factory itself, when you think about the different lines that a factory has, and if you're trying to use, using the drivers of a SCADA system, all the different applications, and this example here shows the various types of applications up above. But in a typical manufacturing environment, you'd have your ERP, MES, the cloud, whatever advanced analytics and IoT type applications, AR, augmented reality. There's just a lot of applications that need data today. And if each one of those applications were to ask the data sources, for specific data points, that's just a lot of unneeded data requests going across the network in that factory. By putting an architecture like this, where you could have these little gateway data collectors at each line or even at each machine, depending on what's needed, it again can be collecting a lot more frequent data, and same benefits then apply for being able to provide that data locally. If there's a local HMI for the operator, he could tap into that and be able to get that data. But that same server then could be providing that data, not to just plant management type systems, MES, ERP, like I said, all the way up through the stack, without having to have all these redundant data requests hitting your devices.
Yeah, got
Does that
it.
help, Matt?
Yeah, thanks for clarifying that. That definitely helps, just to kind of put it in some other context.
Yeah, I know not everybody's in an oil and gas environment for sure.
Yeah, no problem. And just one other comment to the group. If you guys have any questions or comments, I forgot to say this in the beginning, feel free to just type them in the Q&A window. We'll answer them as we go. We can interact like we're talking about. Like I said, if you're brave too, you want to raise your hand, feel free to do that throughout this session. We'll chat with you. So go ahead, guys. Sorry to interrupt.
That's great. No, and I think, oh, and then just as, we mentioned these black boxes here with the Kepware logo on it. So partners that are participating in this discussion today, like I said, we're sandwiched in between them. The Stratus CTC Edge device and the Moxa 2201. These are just examples of the type of gateway type devices that we that we're working with, that the software would reside in, and these would be deployed closer to the data sources, as opposed to, like I said, in the traditional server closet or server room. All right, and I'm pretty sure that's it for me. And now I'd like to turn it over to Kyle, who's going to talk more about technology in general, and the topic being containers.
Awesome, thanks, Steve. Yeah, so I'm gonna do my best here to try to educate you all on containers in 10 minutes. We'll see how we do. Before I get started, just a quick disclaimer here. So a lot of you that are familiar with Kepware kind of really know its capabilities and know that we play in a lot of different environments. We're connectivity, we're industrial connectivity, and due to the nature of our product, we are into a lot of things like Active Directory, or we know a little bit about, or hey, we know a little bit about like Azure integration and all that, but by no means do we pretend to be experts in those fields. So we like to almost consider ourselves like, hey, we're subject matter experts when it comes to things like OPC or industrial protocols, things like that. But we're more subject matter aware for some of these other environments that Kepware plays in. So quite simply saying like, hey, we'll tell you how to connect up to the cloud from Kepware, and we'll show you all that. But in terms of your cloud infrastructure, that's not really our expertise. So with that being said, I want to talk to you all about the idea of containers and what this means and why it's important. And right off the bat, the whole reason we're talking about this is Thingworks Kepler Edge, and I believe its next release is going to have the option to be sold as a container. Now, you may be hearing containerization or containers for the first time, and that's totally fine. It's more of an IT technology making its way over into the OT world, very similar to how like Ethernet IP and managed switches kind of made its way from the IT side to the OT side of the fence. So from a very, very high level standpoint, we'll talk about containers here. So the best way to explain this is, hey, let's look at the history of how software was typically deployed out on the plant floor. So way back in the day when there wasn't, VMware, as everyone is very familiar with, if you wanted to have multiple applications out there on separate machines, you just quite simply had to buy a new physical machine, right? So, hey, maybe I've got my, GE server over here, and maybe my historian is on a different piece of hardware, but the point is it had to be two physically different pieces of hardware to host that software. So how do we help fix that? Well, obviously it's now a VM image or virtualizing all of those things. So now with VMs, you can have virtualized operating system, virtualized machines, all residing on a single physical piece of hardware, which is awesome. There's a lot of flexibility there. Makes deployment much easier. and it's great. But where it starts to fall apart is that there's a lot of unused stuff potentially within that. So, let's even take, go back, Steve.
Sorry.
No worries. If you look at even Kepware, it's a very, very lightweight software. It doesn't take a whole lot. But let's say, hey, in this architecture I have, it just makes sense for me to have Kepware on its own virtual machine and not, placed with another one. Okay, that's great and that's awesome. But now you have to stand up a full operating system with a bunch of stuff that Kepware doesn't need to run on this virtual machine. So you essentially have a lot of bloat onto this one VM. So when we look at, what Steve was talking about the edge, where, hey, we've got maybe 1,000 of these devices out there that are probably a little bit more lightweight in nature, right? So they don't have a powerful RAM going. Maybe the memory is very small. But hey, we want to deploy all this software with full functionality, without sacrificing that functionality at the edge. You could do that with a VM, but it's probably not the best way to go. There's just a lot of bloat in there. So that's where containers and containerization technology steps in. You can almost think of it from, again, a very, very high level point of view of a container being almost like a virtual image with no operating system on it. So another way to say that is like, hey, we've got this virtual environment with one application on it, but none of the other junk that the application doesn't need. So it's really just stripping out all of that fat. And then it allows that container to be very flexible in terms of deployment, in terms of sort of orchestrating where it goes, how it functions, all that good stuff. So very high level. It's been in IT for a number of years, but it's now making its way over to the OT market. Vanna, if you could, next slide. Thank you. Just a little bit of buzzwords here, a little bit of different software companies to check out. I know that sounds kind of goofy. We are, PTC, we're trying to sell you software, but again, subject matter aware. We want to make sure we give you guys the tools to go out and do your own research. But, let's say, hey, I've got my container now. What do I do with it? It's just this VM thing. How do I go out and how do I make sure it gets deployed correctly? How do I make sure it's networked to other containers? Things like that. So couple of logos on the screen here. Top left, this company / software called Docker, very open source, but essentially think of Docker as, hey, this is a way for me to create a container. Similar to almost like what VMware does, but you can go in, create a container, do all sorts of different things. Could you create a container without using Docker? Yes, no idea how. But Docker is really the way to create those containers. And then that kind of ship looking thing in the middle is this company called Kubernetes. And Kubernetes is it's an orchestration platform. So it allows you to do things like, hey, I've got my container, now I need to deploy it to all these edge devices. I want to monitor the health. I want to network multiple containers. Hey, I want to make sure security is good. I want to do some load balancing. All of that stuff is done automatically through Kubernetes. So the OT kind of metaphor I like to take is it's almost like a batch server in the sense where, hey, there's a lot of things going on in the background, and hey, in my batch system, I've got this particular asset running at an idle state or at a holding state. Okay, what does that mean? How does my overall system act? All that stuff happens in the background. So what Kubernetes is doing for all of these containers deployed. And then down at the kind of the two bottom corners there, you have AWS, and then over to the left is actually something called Azure Kubernetes Service, which is just a subset of Microsoft Azure. Kubernetes really is the gold standard of orchestration for most, if not all, cloud platforms. And in fact, you'll actually see AWS, Microsoft, Google sort of building on top of Kubernetes for their own container orchestration services. Again, so a lot of stuff to get into there. We won't cover it here, but it's a good way to kind of get you guys started to kind of look at, hey, what should I be looking at if I want to learn more about containers or container orchestration? Next slide, please. So ideally, this is kind of what we would want at the edge. So if we think back to Steve's example of, hey, we have this one server out on an oil field somewhere. on that small edge node, whether it be you know, a Stratix box, a Moxa box, whatever, what would we want on it? Well, you know, we'd want some sort of connectivity. We'd want maybe some sort of data analytics. Maybe we'd want some sort of contextualization, whatever. That's a lot of good stuff that we want in this node that probably has a small operating system. So we want to be able to deploy all those things, but also we want to make sure that we have status healths and making sure that you know, it's operating at a state that we want it to, all that stuff. So really the containers, the container orchestration helps us get more stuff into a smaller box and then be able to easily deploy it. So that's sort of focusing on specifically the node, but next slide, please. But if we bring it out a little bit, now, hey, maybe this is what it looks like from a larger architecture standpoint. Again, this is very, very simplified, but maybe it's, you know, hey, I'm a developer. I have Thingworks Kepler Edge in a container ready to go. I do my configuration of it. I put that into my container registry, and then my Kubernetes service helps deploy and manage that particular container on all of these different devices. So really that's the gold standard we're working towards. And we believe that containerization and container technology is the way to help us get to that scalability issue that we see in IIoT environments. Next slide, and I think that might be it. Oh, and then just a basic roadmap here coming up. I got a little 2 minutes left here. Just sort of a roadmap for Kepler Edge. So for right now, we do have ThinkWorks Kepler Edge available in a beta for a Docker container. That's available now. If you are interested, please you know, reach out to the folks at AutomaTech. They can put us you know, in contact with us. In the future, we are looking at maybe moving that to more of a specific Microsoft Azure IoT deployment, so specific to the IoT hub. We are looking at things like, hey, we want to do a local license server for Kepler Edge just to make licensing a lot simpler and a little more streamlined. We are also looking into things like ARM architecture support. So for right now, Kepler Edge is x86 processors only. We are looking into getting that onto ARM architectures. That was a big ask from our customers. And then we're also looking at things like, again, different drivers, and then maybe even a simple GUI for Kepler Edge. So that brings us right up to the half hour.
Yeah, great job, Kyle.
Yeah.
Way to
Hey,
get
Kyle,
all that information in
just a quick comment, question on my side here. So for the group, AutomaTech actually was involved in some of the early beta testing with ThinkWorks Kepler Edge. Pretty cool stuff. You know, we had an application where we were testing this out for the folks where we had a Windows-based full Kepware server that was running Modbus protocols, Modbus drivers. We were able to take the same configuration and deploy it off to Kepler Edge version running on Linux with you know, the same features, functions, and capabilities. So it was really cool to be able to just do that and now be available in more of a smaller, compact you know, platform. So related to that, guys, do you have any other application examples or, you know, stories where you've got some other customers that have been using this and reasons why?
Docker specifically or Edge?
No, Edge specifically, not so much on the Docker side, but Edge in general.
Yeah, so one of them is more in the works now, but we have well, I guess we'll call it like a machine builder that makes overhead cranes. And they're looking to, hey, we want to collect data from our cranes just for, you know, just like maintenance and support or over the wire troubleshooting, things like that. And in the past, you know, it's an overhead crane. It's not going to be roped into a SCADA system. It's not going to be integrated into the factory. It only does a few things. So their thought was, hey, we've got, you know, 20,000 of these things. How are we going to get out there and put a device on this crane that's not a full-blown computer, you know, all that stuff. So the idea was, hey, let's just put a smaller, you know, Edge hardware device on it, throw Kepware into it, or Kepler Edge, and then actually send that up to Thingworks. So it's more of that, like, hey, larger architecture. It's not part of a bigger factory. There maybe isn't necessarily that good solid infrastructure there. That's sort of the use cases that we've been seeing. Is, hey, I have a lot of deployments, maybe not great physical infrastructure, but I still need connectivity.
That's definitely a great use case, being able to take the power of Kepware and deploy it in more of a small footprint, you know, limited capabilities approach. That's a great story for it. There was another question that came through during the session. Steve, I think this goes back to the example that you had, more of a remote distributed architecture. So the question was about report by exception communication. So traditionally in some remote applications that can be done through protocols like DNP3. Do you get the similar kind of functionality with the Kepler Edge solution like you would with DNP3, where the device can actually store the data and then forward it when a connection is lost and reestablished?
Yeah, so can you guys still hear me? Just want to make sure. Yeah. So the ThingWorks Kepler Edge version 1.0 is not able to store the data today. That is something that is on the roadmap to do, and to also include that in the regular Kep server product as well. Because yeah, when you're at the edge, that's definitely something that's going to happen. And there is other technology that could be put in that gateway device to handle that as well. But in general, like it's great if you have a device that supports DNP3. This more takes care of the type of devices that are out there that don't support a protocol like that or have the ability to store the data locally at the device. You know, when you think about brownfield, all the Modbus devices that are out there that just don't have that capability.
Okay, great. Yeah, thanks for clarifying. I don't know if there's any other questions or comments from the group here. If you guys have any kind of parting or final words, it didn't really see a lot come through here on the chat window. Oh, I did get somebody that made a little DNP3 love heart emoji next to it. Thanks for the comment there.
Yeah.
Kepler has that protocol too, so that's another option.
We definitely do.
Now, I'd say if there's any future, any questions that you want to dive deeper with, reach out to Matt, who can get us all together and talk about it.
Yeah, awesome. Thanks, guys. This is a great information. Excited to see the new technology from you guys here. And again, for the group, if there's any questions, just let us know. We'll follow up with all the slides and all the content. Thanks, Kyle. Thanks, Steve. Appreciate it.
Thanks a lot for having us.
Thank you, guys.
No problem. Take care, guys.